Alright, so it's time to work some examples. So you'll need your scratch paper, pencil, eraser, calculator, periodic table, and your polyatomic ion sheet would be helpful. Okay, so gather those things together and then you can work some examples with me. Alright, so the way I'm going to show you how to solve chemistry problems using conversion factors, which is also used what's called stoichiometry or the factor label method, is the easiest way to solve chemistry problems. You will see, some of you can see how a proportion could be used, and that is an easy way to set up chemistry problems. So for those simple type, you can use a proportion. I don't like to confuse students and have you do a proportion for this type, but you can't use a proportion for these others because they're more complex. So if you're very math fluent and you feel comfortable using proportions and you can see when to use one and when you shouldn't, then go right ahead. Okay? All right. So we have a question here of how many moles are in 5.00 times 10 to the 6 atoms of calcium. Well, I know that for every 1 mole of calcium, there are Avogadro's number of atoms of calcium. So we can write that as a conversion factor that allows us to convert between moles and atoms. So I'm going to start off with the given. And I'm going to use the dot for my multiplication. And I need to cancel my atoms. So in order for things to cancel, the atoms have to go on the bottom. And 1 mole goes on top. So this is just a whole number times a fraction that equals 1. So if you have to help your brain operate a little better, you can make this like a fraction, and so then you're just multiplying fractions. And when you multiply fractions, you have to multiply the numerators and then divide by the product of the denominator. And that's how you're going to put it in your calculator. So you're going to have to follow the order of operations in order to get the correct answer. So I know when I multiply times 1, it doesn't change anything. Likewise, when I divide by 1, it doesn't change anything. So these two things really are just these numbers. And so that makes this an automatic division problem. Okay? So in our calculator, we can take the given, and we're dividing by Avogadro's number. And I'm going to put it in parentheses because it is this large number. That's scientific notation. So you will have to use parentheses, or if you have a graphing calculator, use the alpha function. Or if you're using the Desmos calculator, I'm not very well schooled in the Desmos calculator. I know your teachers are, so that's something you might want to use also. Alright, so this is important to figure out what the final right answer is, because we have to follow order of significant digit rules. And actual numbers that are exact, like Avogadro's, don't count in that calculation. So the given is the thing that determines the exact number and our final answer. So, and the fact that this is times 10 to the 6 doesn't change anything. So we have 1, 2, 3 final answers, and our final answer, or three significant digits in our final answer. So 1, 2, 3, look to the right, round down, and this is 8.3 times 10 to the negative 18, and then atoms cancel, so we're left with moles of calcium. Okay, this could be set up as a proportion. Okay, you would just take X moles over atoms and then do moles over atoms and then cross multiply and divide. You'd get the same answer. Okay, so let's try the next example. How many moles are in 4.5 times 10 to the 3 molecules of water? So I know that for every 1 mole of water, is equal to Avogadro's number of molecules of water. And I'm going to abbreviate molecules. We start off with the given. I'm going to multiply that times 1 mole of water over, because we want molecules to cancel, so that has to go on the bottom. And then this just becomes another division problem. And we have 3 significant digits, so and since this is smaller than a whole mole, I expect my final answer to be pretty small too. Okay, that's the next example. How many moles are in 2.33 times 10 to the 2 formula units of sodium chloride? Well, I know that for every 1 mole of sodium chloride is equal to 2.33 times 10 to the 2. And I'm going to abbreviate. Okay, start off with the given. And I need formula units of, oh, sorry. Whoops. I'm not paying attention. Goodness. I was just looking at that number and wrote it. Oh my. Okay. So I need formula units to cancel, so that has to go on the bottom. Oh, 1 mole sodium chloride. Becomes a division problem. So we have 3 significant digits, so 3.87 times 10 to the negative 22 moles of sodium chloride. Okay. So factor label method is the easiest because that just tells you then how to, and we can keep adding more and we can make more complex problems, and we will. We'll get to harder ones. So again, this is one you can set up a proportion for. All right, now what about atoms given moles? I bet you can figure this out already. I'm not even thinking here. I'm doing it again. Look, this is 2 times in a row that the number is right there in front of me and I'm writing the number. It's like I'm on automatic pilot or something. Okay. So now we're going from moles to atoms. And since I want mole to cancel, that has to go on the bottom this time. And now this is just a simple multiplication because dividing by 1 doesn't do anything. Three significant digits, 1, 2, 3, look to the right, round down. Okay, so we do expect to see a little bit larger number, a little smaller number because you're multiplying by a fraction than Avogadro's number. Okay, a little more than half. Alright, so moles of aluminum cancel, and you're left with atoms. Look at the next example. How many molecules are in 1.25 moles of methane? Okay, start with the given. Since I need moles to cancel, that goes on the bottom. Moles cancels, and this is a multiplication problem. Three significant digits. Look to the right, round up. Okay. Since we have a little bit more than a mole here, I expect that number to be a little larger. Alright, again, all of these can be set up as a proportion. And if you need me to send you a personal video on how to use a proportion, I can do that for you. Alright, these are a little different. Okay? So, no, this isn't different. I'm not there yet. Sorry, I apologize. How many formula units are in 0.5 moles of potassium hydroxide? Well, for every 1 mole of potassium hydroxide, we have Avogadro's number of formula units. Start off with your given. Okay, I need moles to cancel, so it goes on the bottom. And I need formula units at the top. Okay, moles cancel, and then we're just multiplying. And we have 2 significant digits. Alright, since we have half a mole, that should be a half of what a mole is. Alright, so these are pretty easy and straightforward because you can even use a little mathematical reasoning to figure out what your answer should be. But when we get into more complex ones, that doesn't work like that. So this factor label method becomes a very important way for you to solve many types of chemistry problems. Okay, so you do want to practice using these, although a proportion can be used for these particular types, and I prefer not to show multiple ways just because it confuses people because they don't know when to use a proportion and when not to use a proportion. And this would be an example of one of those times when you can't. I guess you could do multiple proportions. Alright, there are 2.33 times 10 to the 6 atoms of phosphorus in a sample of phosphoric acid. How many moles are in the sample? Well, a couple of things we already know. We know that for every 1 molecule of phosphoric acid, there are 1 atom of phosphorus, right? Right? And since we're converting between atoms and moles, I know that 1 mole of phosphoric acid is equal to Avogadro's number of molecules. Okay. So in a formula like phosphoric acid, this is kind of an interesting little thing you can convert between within things. Within one molecule, you have one atom. So in a formula, these can also be used as moles later when we talk about other things, and we actually do that when we talk about empirical formulas and molecular formulas. These actually can be used as moles. So there's lots of different interchangeability with these units of moles that we can use. Okay, so again, we start off with our given. And since I want atoms of phosphorus to cancel, I'm going to use this one. For every one molecule. Okay. Now we're left with molecules. So you could do one proportion, and then the answer of that one could be put in the other proportion. That's just more work if you ask me. It's just easier to put these together like this. So now I need molecules to cancel, so I'm going to have to put Avogadro's number on the bottom. And then mole on top. Okay, so now order of PEMDAS becomes important, or order of operations, or PEMDAS becomes important, but we're lucky in that these are just ones, so that really doesn't change a whole lot. And again, you can make that a fraction. So 2.33 times 10 to the 6 times 1 times 1 is just 2.33, and 1 times that is just Avogadro's number. So, and if you want to string them all together and put them, in your calculator, you can do that. And we have 3 significant digits, so that's going to round to the, and then that ends up being moles of phosphoric acid. Okay, so that's an example of atoms of an individual molecule, how many moles of that phosphorus is in that sample. Okay. And then you can also do it in reverse. Oh, I guess I should have showed you how molecules cancel. So this is just going to be the same kind of problem, but in a different order. Okay. We're given moles, find atoms of a molecule. Well, I know that there are 6 atoms of carbon in one molecule of glucose. And I know that for every 1 mole of glucose, there's Avogadro's number of molecules. Okay, so we have since I want moles to cancel, I'm going to put that on the bottom. Oh, I meant for that to be 12. Ah, fiddlesticks. I don't know why I wanted to do 666. That's bizarre. I know what the formula for glucose is. C6H12O6. I think when I refer to glucose, I'll tell you why I'm thinking 6s. Is because when you write the equation for photosynthesis and respiration, all the coefficients are 6. So, sorry about that. I know what the formula for glucose is. Really, I do. Oh my goodness. Alright, where was I? Okay, moles cancel. we're left with molecules. So I want to use this conversion factor. And then molecules cancels and you're left with atoms. Multiply, multiply, multiply. And since this is just multiplication of 1, that will be our final answer. Three significant figures. Alright, there you go. That's how you do those. Okay, so let me know if there's any other examples you need me to work, and we'll move into some more complicated ones as the unit progresses. Okay?